Let's look at how about on page 289, let's look at question 141. So page 289, we're going to look at question 141. And this one just has several steps. So we're going to have to combine like terms, distribute through. These always look more complicated than they actually are. Okay, so this is what we've got here. Always do the parentheses first. And so we're going to go ahead and distribute through this 3. And so when I distribute through the 3, that's going to be 2 to the 3rd power. If there's no number, remember it's assumed to be an exponent of 1, right? Or power of 1. So 1 times 3 is still p to the 3rd here. Down below, we have a q to the 3rd. And then we've got negative 1 gets distributed through. And remember, if there's no exponent, it's assumed to be a 1. So that's going to be 3 to the negative 1st power here. And we've got a p to the negative 4th. And then we've got a q to the negative times negative makes it a positive 4. Now, we need to go ahead and get rid of all the negative exponents. We need to combine them together. And we also need to evaluate down the numbers that are raised to a power. So I'm going to do the numbers first. 2 cubed. 2 cubed is 8, and that's positive exponent. So it stays on the top. Now, what about this 3 to the negative 1st? Okay. It's a negative exponent, so where does it go? Down below. So that comes down as a 3. 3 to the 1st, which is just a 3 there. Now, what about the p's? Okay, they're all in the numerator. So what can we do with these? And I'll do some work over here so we can see. What about the p part? What do we have? We have p to the 3rd, p to the negative 4th, right? Because that's all together here. And what do we do with those? Those exponents are not going to multiply, right? No parentheses. So these add together, and that makes it p to the what? Negative 1st. Is everybody okay with that? So that piece is there. So that's p to the negative 1st there. We'll deal with that negative exponent here in a moment. What about the q's? Okay, they're both down below, right? So we've got q to the 3rd, q to the 4th, no parentheses, so those add together. And that makes it q to the what? 7th. And these q's are all down below, so it stays down below. That's the q part. Now, we're not quite done yet because we have one more step to work through here. Okay, what do we need to do next? Did I copy everything down right? Hopefully I did. Yep, negative, negative makes it positive. Okay, did I mess up with the q here? Oh, yeah, I wrote it down here. That's okay. It should be 2 squared in the original problem, but don't worry about it. Just leave it the way it is, because we've already worked it out this far. So what else do I have to do? I've got one more step left to do. P to the negative 1st. Where does it need to go? Yep, down below. So that then becomes, for my final answer, 8 is the only thing left in the numerator. A 3 is in the denominator. A P and a Q to the what? 7th power. And that is your final finished answer. And again, I forgot to write the 2, so it's a little bit different than the problem in your textbook, because I just forgot to write the 2 there.
Does it matter where you put the key or the P? You have to like put the P before the key?
Nope, doesn't matter, because they're the same. Just make sure they're down below. Make sure they're in the denominator, not in the numerator. And never, ever leave negative exponents. We do have a few loose ends to still cover with these exponents. And we're going to try to add these together here. About 5 to the negative first power plus 8 to the negative first power. Okay, so how do we handle a question like this one? We cannot just simply add the 5 and the 8 together. Even though they have the same exponents, we have addition there. What do we do before we add? Well, before we add with order of operations, we've got parentheses, which we don't have, but then we've got exponents. So exponents are done before addition and subtraction. So we need to rewrite these as exponents. So 5 to the negative first would be rewritten as 1/5. And 8 to the negative first would be rewritten as 1/8. Now you should kind of see what to do. So what do we do with these? Now they're fractions. Now we see how to combine them together. We need a least common denominator. And the least common denominator of 5 and 8 is going to be a 40. So when you have negative exponents, you rewrite them as fractions before you add or subtract. So rewrite them as fractions first. Now we need a least common denominator of 40. So that's an 8 over 8. And this one needs a 5 over 5 here. That is then going to give you now 8 over 40 plus 5 over 40. And we add those together, and that gives you now a 13 over 40. So that is going to be your final finished answer. It is very, very similar to question 6 in your homework. The only difference is instead of adding, it's subtracting. Rewrite that as 1/10, 1/4, and subtract them. Let's double check our zero exponent rule again to make sure we know how that works. Again, this one will be add, so we're going to add these together. This one deals with zero exponent rule. And a lot of times students make mistakes with this one as well. Okay, now, when we cancel out the double negatives, that is multiplication. And before we do multiplication, what do we have to do? Exponents first, right? Exponents in parentheses go first. So each of these, negative 8 to the 0 power, each of these to the 0 power is going to come out to be what? 1. So negative 8, it's got parentheses, to the 0 power. That comes out to be 1. Our negative sign gets dragged down. And what about negative 4 to the 0 power? That is also what? 1. And 1 minus 1 leaves you with a 0. We cannot cancel these and make them positive. Why not? Because you have to do the exponent before you cancel out your signs. That should now take care of all the questions over exponents. I'm going to work out one more of these. There's 2 complicated questions in your homework, questions 13 and 14. I'm going to do 14. 13 is a little bit different. They're all a little bit different, but the same concepts. So I'm going to do 14 in your homework. So we're going to look at homework 4.1. We're going to look at question 14. is kind of the same, but it's different. They're all a little bit different. They all require different rules and different ways of approaching them. And let's double check and make sure that we wrote everything out correctly, because it's so easy to miswrite something. Yep, everything looks right. Okay, now, before we start distributing, order of operations, we do our parentheses first. So the first thing we look at is inside the parentheses, and we see if we can break it down, because that is first. Parentheses are before the exponents. So inside the parentheses, we have x's that can go together, and we've got y's that can go together. So let's look at the x part. On the x part, we have an x cubed over x to the negative fifth. Right? Because that's your x part here. Now, what are we going to have to do? We're going to have to subtract these. Why are we subtracting? Because we're dividing. Be careful with the signs when you subtract them. So that is going to be x to the 3 minus, because we're subtracting, a minus 5. And that double negative here is going to make that now a what? Positive. So the x part is going to come out to be x to the 8th. I'm going to write down the 2 because there's nothing to go with the 2. We've got an x to the 8th because that is my x part, right? All I did was I subtracted them. And when you subtract off a negative, it becomes positive. What about the y part? For the y part, we have y to the negative third over y to the fourth. Again, quotient rule. We didn't do a lot of quotient rules. That's why I picked this one. Quotient rule, we are subtracting. So that's going to be y to the minus 3 minus 4, which makes it y to the negative 7. And what's left over? It's still raised to the negative second power. So let's take a moment to review what we did. First thing we did was we did the inside first. We combined the x's together on the x part using our quotient rule. Right, and watch out for the double negative. So that came down as x to the 8th when we were done. Then we did the y's together because those have the similar base. So they can go together. Now what do we need to do from here? Now we can't combine anything else because a 2, an x, and a y have nothing in common. Well, what can we now do? We can now go ahead and distribute it through. And when we distribute this through, we are then left with 2 to the negative second power, x to the, remember, parentheses make you multiply, x to the negative 16th power. Watch your signs on the y. Negative times negative makes it a positive 14. Almost finished. So what do we need to work with here? Well, we've got all these negative exponents. Now what about 2 squared? 2 squared, we know that's a 4. So that's going to go down below because this one goes down below. Right? And this one also goes down below. So the 4. Okay. Because if you have, I wrote it out over here with positive exponents. I'll make it more clear. Okay, so if I have 2 to the negative second here, that is the same thing as 1 over 2 squared, right? Which then 2 squared is 4. You don't have to put the 1 here because there'll be other things left, because the y is going to be left. You could put the 1, but you don't need it unless everything else is gone. So I just wrote it down here just so you can see it's negative, so it goes down below, right, and 2 squared is 4. So you can either write it like this, or you can just say 2 squared is 4, and it goes down below. Now the x also goes with it.
So if that were parentheses around 2, -2, that would change. It would be a positive on top. Because if I was going back to -3 on this one, -5 to the 4th, it was, I guess that.
Okay, yeah, you have to, okay, this is a positive 2. So we only put parentheses around it if this would have been a negative out in front, right here with that 2 with it, then we would put parentheses around it, but it's not. Okay, so the only time we have to use those is, and if we don't, remember, the exponent here is a 1. So 1 times -2, that makes it a -2. Okay, does that make sense? Does that answer your question? Okay, yeah, I know it's kind of confusing on these exponents because division becomes subtraction and multiplication becomes addition. But we do that. Now, what about the y to the 14th? Does it go anywhere? Yep, it stays there. And I know it's easy to get confused on these. The steps aren't difficult. It's just a matter of applying all the different rules and remembering how they go together. So that would be what you would do for that one. So that's going to be your final answer for question 14. So go through all your steps, break it up into individual pieces if you need to. Remember, negative exponents go down below. And when I have a 2 raised to a negative power, what I usually do is I just write over the side. It's a positive, break it down, and remember it goes down below. But you can also write it like this. It's the same thing. Now we're going to discuss quickly scientific notation. Scientific notation is going to be used when you have extremely large or extremely small numbers. So we're going to be discussing now scientific notation. Used for extremely large or extremely small numbers. These are based upon a power of 10. So I'm going to write them in scientific notation first, and we're going to convert them to standard notation. And then once we understand how to go from scientific to standard, then we'll do the opposite. Then we'll go from standard to scientific. So scientific is going to be on the left, standard will be on the right. So this is a number in scientific notation. 5.4 times 10 to the 4th power. Okay, that is in scientific notation. Now let's see what that would be in standard notation. So to rewrite this in standard notation, we're going to have to add in the zeros. So for standard notation, we have 5.4, okay? Now it is raised to the 4th power. So we're going to have to move it to the right 4 places. So here's my decimal. We're going to move this decimal 4 places. So here it is. We go 1, 2, 3, 4. And we fill in our zeros. So 5.4 times 10 to the 4th power, well, that would then be, if I rewrote it in standard notation, that would be 54,000. You just move it over 4 places. How about minus 8.3 times 10 to the negative 3rd power? Okay, what would that be in standard notation? Well, if it's a negative exponent, it's going to be a very small number, less than 1, and we're going to move that decimal to the left instead of to the right. So we've got a minus 8.3, And this is going to have to be moved 3 places. So we're going to go 1, 2, 3. And we'll fill them in with the zeros. Now that negative still stays out front. Okay, so that negative just comes down. And then what do we have? We moved it 3 places. I always start with a leading 0. So I usually put the 0 in front of the decimal just so we don't lose track of the decimal. So we've got 0.0083. And it's going to be negative. Why is it going to be negative? Because it's negative to begin with. So I just moved that 1, 2, 3 places. Put my decimal there. I brought the negative down. And then I just moved it 3 places. And I always like to put the 0 in front. I put the 0 in front because if you don't put the 0 in front, it's easy to lose track of the decimal point. So always put that leading 0. Now let's do the opposite. Now let's go from standard notation to scientific notation. So how about 530,000? Okay, that's going to be in standard notation, 530,000. What would that be in scientific? All we have to do is we have to move it. So here's my decimal point right here. And how many places would you have to move? There's 3, 4, 5 places. You always want 1 digit, okay, and then the decimal. So 1 place, 1 digit, and then the decimal. So that's going to be moved 3, 4, 5. So that's 5.3 times 10 to the 5th power. Always, always 1 digit at the beginning. So always start with a whole number and then your decimal. Let's do a decimal now. We'll move it. How about 0.0000273? That's in standard notation. So what would it look like in scientific? Well, we count the number of places. Now, what do we always want? 1 digit. Okay, 1 digit and then the decimal. So we're going to move 1, 2, 3, 4, 5, 6. And that would be now 2.73. And that's going to be times 10 to the negative 1, 2, 3, 4, 5, 6. Negative 6th power. Okay, when you convert a decimal to scientific notation, it's always going to have a negative exponent because it's smaller. It's less than 1. If it's a large number, it has a positive exponent. You can also multiply and divide these numbers. So we're going to learn now how to multiply and divide these. And we're going to write our answer in scientific notation. Sometimes it'll tell you to write your answer in scientific notation. Others it'll have you write it in standard. So I want you to multiply these together. Remember with the exponents. When we multiply, these exponents add together. Now the numbers out in front, the coefficients out in front, those get multiplied. So 5 times 8, let's do those first. Okay, 5 times 8 is a 40. And then the exponents here, these add because we're multiplying. And we've got minus 4 plus 9. That makes it a 5. Now, we are not done yet because this is not in scientific notation. We need to make sure it's in scientific notation, and that means 1 digit. Okay, 1 digit and then the 0. So we cannot have this 40. We've got to move it 1 place. And we can now rewrite this as either 4.0 or 4. And we're going to have to add 1 to our power because we moved it to the left here. And so that's going to be 4 or 4.0 times 10 to the 6th power. Because we had to add 1 because you have to have a leading coefficient of 4. You can't have a 0 out in front. Well, when you write it in scientific notation, it has to have a whole number. So not a 0 out in front, and you can't have extra numbers either. It's always 1 digit. It's not 0. And then everything else after that. When we divide, the exponents are going to subtract. So we're going to divide this next one out. So we're going to divide these out. And again, we're going to write this in scientific notation. First thing we do is we reduce. So 8 divided by 10, that's going to reduce down. Okay, so 8 divided by 10, we can reduce those down. 8 over 10, that looks like that's going to reduce down to be a 4/5. Okay. We'll convert this to the decimal here in a moment, but I'm going to go ahead and reduce it right now. We'll deal with that fraction as a decimal here in a moment. And that's going to be times 10. What happens to my exponents here? We are dividing, so what do? We subtract. So that now comes out to be, we'll take this fraction here and we're going to rewrite it as a decimal. Okay, so what about 4/5? 4/5 as a decimal would be what? 4/5 is a decimal because we want it in scientific notation. So we're going to write it as a decimal. That's going to be 0.8. And then that's going to be times 10 to the negative what? 5th power. Is this in scientific notation? No, because we can't have that 0 out in front, right? It has to be a number that's not 0 and only 1 digit. So we're going to have to move this. Okay, we're going to have to move it here. Now, which way did we move it? We moved it to the right. So that means we have to take 1 away because we're moving it, making it larger. So that's going to come out to be 8, or you can write that as 8.0. And that's going to be times 10 to the negative 6th power. Because you're making it bigger. When you make it bigger, you have to take away 1 from the power. Now we're going to use this to work out some applications. And there's 5 applications. I'm going to do 2 of them for you. And then I'll leave 3 of them for you to work out in your homework. All you basically have to do on these is set them up and either divide or multiply. That's it. So I'm going to do, how about I do 21, because that's a more difficult one. And let's do, how about 23? So I'm going to do 21 and 23. When we read these, we have to figure out if it's multiplication or if it's division. So 21, this is from your homework here. Assume that the volume of the earth is 5 times 10 to the 14th cubic meters. And the volume of a bacteria is 2.5 times 10 to the negative 16th cubic meters. If the earth could be filled with bacteria, how many would it contain? Now, when I read a question like this, I use some common sense to think about what my answer is going to be. Is my answer, do you think, going to be really small or really large? How many bacteria fit in the earth? Well, the earth is a great big place, right? Bacteria are very, very small. So there's going to be a huge amount of bacteria, right? So my exponent had better be really, really large. A large positive exponent on my times 10. Now, if I were to multiply, these exponents would do what? These would add together, and I would end up with a small number. I don't want that. It would be less than 1. And we know there's going to be more than one bacteria in this earth. So we're going to divide. We're going to have to take the volume of the earth, okay, and we're going to divide it by the volume of a bacteria. And then that is going to tell us how many bacteria that we can have on the earth. So we're going to divide. So we're going to take our volume, and this is question 21. And you'll know right away if it's the opposite. Because if you look at it and your answer doesn't make sense, if you end up with something with a negative exponent, and that would be less than 1, that wouldn't make sense. So you'd know automatically that you did it incorrectly. You can always check your answer and see if it makes sense. And if it doesn't make sense, it's probably the other way. So this one is going to be dividing. If we multiplied, we would end up with something that wouldn't make sense. So we're going to divide. We're going to take the volume of the earth, and we're going to divide that by the size of the bacteria. And what's the volume of the earth? Well, the volume of the earth is approximately 5 times 10 to the 14th cubic meters. This is so huge. We don't put units on it at the very, very end. And then we're going to divide that by the volume of a bacterium, which is 2.5 times 10 to the negative 16th power. Now we divide, and so we'll just do the numbers first. So 5 divided by 2.5 out in front, that comes out to be 2. And then what about our exponents here? We're dividing, so they subtract. And what happens when we subtract a negative? It becomes a what? Positive. So the double negatives here make that positive. And now we are left with 2 times 10 when we add those together to the 30th power. And that's going to be the number of bacteria. And does that make sense? Is that what we would expect? Okay, if we wrote this out, this would be 2 and 30 zeros behind it. Is that what we would expect for the number of bacteria in Earth? Yeah, right? Makes sense, wouldn't it? Okay. If it came out to be a negative exponent, it wouldn't make sense. Because we know there are a lot of bacteria in the Earth, so that had better be positive. I also said that I would work out question 23. And it's similar, but it also is a little bit different. You have to read it and see what your answer is going to be. So 23. If the speed of light is 3 times 10 to the 8th meters per second, how long does it take to travel 2.29 times 10 to the 11th meters, the distance from the sun to Mars? Okay, so we're looking at the speed of light. And the speed of light is very fast. Is it going to take the speed of light very long to get to Mars? No, it shouldn't take it a long time, right? Might take it a couple minutes to get to Mars, but it shouldn't take it a really, really large amount of time. Now let's think about what we've got. This is a distance problem. Speed of light, that's a rate. This is the distance, right? And we want to find the time. So for question 23, we go back to our distance formula. So let's look at our distance. What's our distance here? Okay, our distance to Mars is 2.29 times 10 to the 11th power. That's the distance. How fast is the speed of light? Well, the speed of light, r, that's your rate, is going to be 3 times 10 to the 8th. And we don't know our time, so that's what we don't know. So let's fill things in. Okay, because that's our distance, right? This is the distance to Mars. This is our rate of speed, how fast the speed of light is, and this is going to be our time. Now again, we just plug the numbers back in. Okay, how do we solve it? We need to get the t by itself. We just divide. Nothing new here. And now we can rewrite it and we can do our scientific notation division. So when we divide, we now have 2.29 times 10 to the 11th power over 3 times 10 to the 8th. Okay, is everyone okay with how I did that? So I just rewrote our distance formula because it's a distance type of problem. There's our distance, there's our rate, unknown time. Now I did have to solve it, so I divided just like we normally would with any other number. Now we have to divide and subtract our exponent. So 2.29, going to divide that by 3, and that comes out to be, we'll just take this out to 4 places. Normally 4 places is more than enough. So when I divide those out, I get 0.7633 if we round. What about the exponents? Okay, that's 11 over 8, so we subtract. Okay, so 11 minus 8, that makes it a 3. Now, what does it want? It says, express your answer in scientific notation. And we're going to go ahead and get this in scientific notation. So what would this be? In terms of scientific notation, we've got to move it, what? One place. So this would be 7.633 times 10. Okay, we're going to have to move it back. So it's going to be times 10 to the second. And that's going to be in scientific notation. But let's see what that would be in terms of standard notation. So this is scientific notation. What would it be in standard notation? Okay, in standard notation, you'd have to move this, okay, times 2, so 2 places. So that's about 763 seconds. Or about how many minutes? Okay, divide that by 60, or about 12.7 minutes. Does that make sense? Because on these, you need to make sure that what you get for your answer makes sense. Does that sound reasonable? About 12.5 or about 13 seconds for light to reach Mars from the sun. Does that make sense?
Yeah.
It does, doesn't it? Right? Because that's kind of what you would expect. If it was going to be hours, that wouldn't probably make sense, or even years. Speed of light is very, very fast. Now, if we were sending a rocket to Mars, it would be in terms of years. You would expect it to be a much, much larger number because a rocket, of course, is much slower. What they wanted, though, was they wanted it in scientific notation. So this is what they actually wanted. Okay, in terms of scientific notation. So move that over. I went ahead and wrote it in standard notation just so you could understand what it really is. Because sometimes scientific notation, we lose track of how big or how small that number really is. And that's 763 seconds, which sounds like a long time, but remember, 60 seconds in a minute. So if we divide it, it'd only be about 12.5 or 13 minutes, which that seems reasonable. And that's what you need to make sure when you work these out and you get your answer. Make sure it seems like something that makes sense for the particular problem. If it doesn't make sense, try the other way. If you divide it and you got something that didn't make sense, try multiplying. See if it makes sense in that way. We're now going to move on, and we're going to look now at multiplying these polynomials. So we're going to go ahead and move on and look at multiplying these polynomials. And it's actually 4 or 5 instead of 4, 4. But we're going to look at multiplying polynomials. We'll do a couple of these, and then we'll take a short break, and then we'll come back and finish them up. When we multiply these polynomials, we are going to be adding the exponents together. Right? Because when you multiply, the exponents add. Now, the addition or subtraction is going to separate the terms. A lot of you are probably already familiar with this, but we're going to review it again. It's very, very important we know how to multiply so that when we get to factoring next week, which undoes the multiplication, it makes sense. So let's remember how we would multiply and distribute through something like this. Let's say we got 5x to the 4th, z to the 3rd, and then we're going to multiply that by 2x to the 5th minus 7x to the 9th, z to the 8th. Okay, so I'm going to go ahead and have you multiply this through. First thing we do is we do each term and we distribute it through, just like we always would. Nothing new here, just like we would normally distribute through. Now, these exponents are going to add together. These are called coefficients out in front, the 5 and the 2. And those coefficients, they just multiply together. So the 5 times 2, that makes it 10. Now, how many x's do we have on the first piece? Well, we've got 4 and 5 more. That makes it x to the 9th. Z to the 3rd. Now we do the next one. We distribute that 5 times that negative 7. And 5 times negative 7, well, that's a negative 35. And how many x's do I have here? I have 4, right? Plus 9 more. That makes it x to the what? 13th power, right? Add together. What about the z's? How many z's do I have? I have 3, right? And add 8 to that 3. That makes it z to the 11th. Now, you could leave it like that, or you could rewrite it to where the highest power of x is first. So this is acceptable. Or you could also write this as this. Because highest power of x, we can write that one first. Most of the time, we write the highest power of the x first. And then we go down from there. So either one of these is the same. Most of the time, though, the highest power of x is going to get written first. But these are the same. Let's try another multiplying and distributing through.
Why doesn't the z, like the z3, why does that move down instead of, like, because you know how we move down x to the 9th right there?
Right.
So why do we move down z to 3?
Oh, this one?
Yeah, why didn't that just go to z to the 11th?
Okay, because if there's nothing here, it's z. It's basically like having a z to the 0 power.
Oh.
And then we add them, and then we have 3 plus a 0. See, that makes it a 3. So we don't write it here, but it's actually there.
Okay.
It's kind of like having a 1 out front. We know it's there, but we don't write it. So we are basically just adding a 0 to it. So there's nothing to go with it, so we just bring it down. And we're adding, we're not multiplying. The very, very important takeaway is when we do these exponents add together. The coefficients, the numbers out in front, they multiply through. And either one of these is the same. So either one of them would be a correct answer. Let's try another one. How about minus 9 z to the 4th p to the negative third times 5 z p to the fifth, let's say, minus 1. Okay, so this one, again, multiply through. So go ahead and multiply through. Minus 9 times 5, well, that's a minus 45. Let's collect our z's together. Remember, if there's no number here, that's like a z to the first. So there's actually a 1 there. We don't write it, but it's there. So there's 4 of them. Add 1 more makes it z to the fifth. What about the p's? How many of these do we have? We have minus 3 plus 5. That makes it a p to the second power. And then we distribute through the negative. So negative times a negative makes it a positive. Okay, and then we've got a 9, z to the fourth, p to the negative third. Now, in this section, you can either leave that p to the negative third as a negative exponent, or you can rewrite it. In 4-4, normally we'll leave it as just a negative exponent, so you're not going to have to rewrite it. You could rewrite it, but in this section, you can leave it as a negative exponent. In 4-1, when you work with it, you're going to have to rewrite them. But in this case, in 4-4, you can leave it as a negative exponent. You can rewrite it as a positive one by writing it down below. Right? You could rewrite it as this, but you don't need to. They're the same. Right? These are the same. So either way is acceptable. Let's go ahead now and take a short break. When we come back, we're going to talk about foiling. So we're going to learn how to FOIL these polynomials together, and then we'll learn also how to multiply things that are too big to FOIL. So let's take about a 10-minute break, and let's be back here about 10:30.